Okay, so this is an example of the type of problem we might see in Learning Objective 2 for our electric potential and capacitance unit. And basically these problems have to do with conservation of energy. So in this scenario, we have a positive point charge and we're calling that Q1, and it's just sitting at a fixed location. And we're taking another object which has a charge Q2 and we're making it come towards Q1. Now, Q2 has a negative charge, Q1 has a positive charge. What we're told is that when Q2 is at a distance of 0.4 meters away from Q1, it has a speed of 800 meters per second. And then we want to know when it gets to 0.2 meters away, how fast is it going to be going? So I've called our points that we're looking at, 0.1 and 0.2, and sort of labeling everything like that. This is conservation of energy, so we're going to be talking about the potential energy at 0.1 plus its kinetic energy at 0.1 is equal to the potential energy at 0.2 plus the kinetic energy at 0.2. Now, the potential energy at each of these points is going to be due to the two charges and their separation. So this will be equal to K Q1 Q2 over R1. The kinetic energy is going to be 1/2 m2. I made it mass 2 because it also goes with charge 2, so hopefully that makes sense, but it has a velocity at 0.1, so I'm labeling it at V1. And then this is equal to K Q1 Q2 over R2. So we're looking at, what is the potential energy then at 0.2 plus the kinetic energy. So pretty standard conservation of energy. The difference is right here is, we're talking about potential energy due to electric charges, which is newer to us. So I'm going to take, what I want to do is I'm trying to find velocity 2. So I want to get this whole term all by itself. So this is going to be K Q1 Q2, and I'm going to have 1 over R1 minus 1 over R2. So basically what this has done is I've taken this term and I'm putting it over here. And then I have plus 1/2 m2 v1 squared equals 1/2 m2 v2 squared. So you see that I've worked on getting velocity 2 isolated. At this point, I actually did put in numbers. So the whole left-hand side these are all my numbers there. Just reminding you that we were told that the mass of the object number 2, that's coming at our stationary object was 4 times 10 to the minus 3 kilograms. It was moving with a speed of 800 meters per second when it was at 0.1. And then this is all going to be equal to the kinetic energy it has at 0.2. So this ends up to be, the first term is 3375 plus 1280 is equal to 1/2 m2 v2 squared. And then I was able to solve for v2. So I take these two terms added together are just equal to this. I multiply by 2. I'm going to divide by the mass and then take the square root of all of this to get my velocity, and I get a velocity of 1,526 meters per second. And that makes perfect sense to me because the two charges are oppositely charged, so they are going to be attracting each other. So the charge 2 is going to speed up. And so it seems like it's speed up a reasonable amount as it gets to that closer distance.